Dear students, today our new chapter Anatomy of Flowering Plants. Okay, in this chapter Anatomy of Flowering Plants, we will take plant tissue. We will study about plant tissue. Learning what anatomy is. Anatomy is basically internal structure of hair plants. So in this chapter, we have to study internal structure and their organization of flowering plants. In this internal structure and organization, we are going here to explain the plant tissue. So let's start our first topic, which is plant tissue. What tissue is? We are aware about that higher plants have complex organization. There are different types of cells which are performing different functions. But these cells perform these functions in clusters, and these clusters of cells are called tissue. So tissue can be defined as cluster of cells. Cluster of cells perform a function, have common origin. Okay, cluster of cells which perform similar function, and have common origin is called tissue. So in plants there are different types of tissues. For example, if this plant tissue, we can say meristematic tissue, permanent tissue, secretory tissue. So this plant tissue, it has different types: meristematic tissue, permanent tissue, and secretory tissue. This permanent tissue has further simple permanent tissue and complex permanent tissue. And this permanent tissue further has parenchyma, collenchyma, sclerenchyma, and this complex tissue has xylem and phloem. This sclerenchyma is further fibrous and sclerous. So this is whole tissue system of a plant, of a flowering plant. Whole tissue system of a flowering plant. It has meristematic tissue, three types of tissues: meristematic, permanent tissue, and secretory tissue. And permanent tissue, we will explain here meristematic tissue completely. Here, permanent tissue has simple permanent tissue and complex permanent tissue. And simple permanent tissue further differentiated into parenchyma, collenchyma, and sclerenchyma. This sclerenchyma has fibrous and sclerous, whereas complex permanent tissue has xylem and phloem. So we'll take these permanent tissue and secretory tissue later on. Today we will discuss this meristematic tissue. What meristematic tissue is? Okay, this is all plant tissues, different types and subtypes. Okay, let's take meristematic tissue. What this meristematic tissue is? This meristematic tissue is actually actively growing tissue. Actively growing tissue. This tissue is actively growing. That means this tissue, it exhibits power of division. It exhibits power of division and differentiation. So, in embryonic stage, this meristem, all the cells of this meristematic tissue are actively dividing. When the further growth occurs, this actively growing region, it gets restricted. It gets restricted to some portions which gives rise to meristems. Which gives rise to meristems. Okay, and these meristems are, we can see here, these meristems are here. Primary meristem and secondary meristem. This primary meristem further is apical meristem and intercalary meristem. This meristem is primary meristem and lateral meristem. Lateral meristem, and this primary meristem further gets divided into apical meristem and intercalary meristem. Before going to explain these primary meristem and lateral meristem, I am going to say some characters of this meristematic tissue or meristem. Okay, what are the characters of this meristematic tissue? This tissue characters, this tissue varies in shape. For example, it has circular, polygonal shape. Okay, circular, polygonal, etc. It has prominent nucleus. Prominent means large nucleus. Prominent nucleus with dense cytoplasm. With dense cytoplasm. It does not store, it does not have reserved food. It does not have reserved food. Okay, these are some characters. It has more characters, but there are some characters, basic characters, which this meristematic tissue possesses. It varies in shape, it has different shapes like circular, polygonal, etc. It has prominent nucleus with dense cytoplasm. It does not have reserved food. That is, food is not reserved in these cells, in meristematic cells, because they are actually dividing cells. Okay. Now we take primary meristem. what primary meristem is. Primary meristem. This very actively growing region, okay, present on different parts of plant, and it has, as I told you, it has apical meristem and intercalary meristem. What apical meristem is? This apical meristem, it is group of cells present at the tip of roots and shoots. Group of cells which are highly divided, which have potential of division, group of cells which have potential of division, present on shoot and root tip, present on apical portion of root and shoot. So we call it shoot and root tip. If they are present on shoot, we can say shoot apical meristem. And if the cells are present on root, this is called a root apical meristem. Okay, this apical meristem has group of cells present at the tip of roots and shoots. If present on shoot, then shoot apical meristem. If present on root, then it's called root apical meristem. Okay, now intercalary meristem. This intercalary meristem, it occurs at base of nodes, internodes, base of leaves. In node, we can take example mint. For example, mint. In internodes, we can take, for example, monocots like grasses. In leaves, base of leaves, we can take example pines. Okay, and this intercalary meristem, when this apical meristem it continues grow, some part of this apical meristem left behind, which help us in some part of this apical meristem left behind, which help us in growth in length. And these portion, the portion which left during the apical meristem, formation of apical meristem, when apical meristem continues to grow, it gives rise to leaf primordia. Some part of this portion it remains and gives rise to new meristem called intercalary meristem, which help us in growth in length and is present on base of nodes, internodes and leaves. This is intercalary meristem. Now lateral meristem. Now lateral meristem. This is type of meristem. Meristem has primary meristem and lateral meristem. Primary meristem has apical meristem and intercalary meristem, and this lateral meristem gives rise to lateral growth. It gives rise to lateral growth. Okay, this gives rise to lateral growth. This lateral meristem. It shows secondary growth. Secondary growth. For example, vesicular cambium, intrafascicular cambium, cork cambium, okay. These are lateral meristems which help us in secondary growth, because all vascular cambium, intrafascicular cambium, cork cambium, these all help us in secondary growth, that means growth in girth, in lateral growth in girth. It increases girth. It increases the lateral meristem. This meristem and stripes, it was based on the position. Based on meristem was meristematic tissue based on the position of the plant. When we talk of based on the origin and development, this meristematic tissue has different types. Okay? Let's see. This was all about position in the plant. And if we say based on origin and development of plant, this meristematic tissue has promeristem, primary meristem, and secondary meristem. Okay, apical meristem was based on position, but based on origin and development of plant, meristematic tissue has promeristem, primary meristem, and secondary meristem. This promeristem, it originates from embryo. Because embryo is undifferentiated mass of cells. Which have power of division. So it originates from embryo. It's also called primordial tissue. It's also called primordial. Okay. Now this embryo, it has limited number of cells. Which have power of division, and this power of limited number of cells, it gives rise to primary meristem. So if we say the origin of primary meristem is this promeristem. Promeristem gives rise to primary meristem, which gives rise to differentiation of plant parts and tissue, further differentiation of plant parts and tissue. This primary meristem, it originates from promeristem, because promeristem has a group of limited number of cells which have power of division, which forms a tissue, small tissue known as primary meristem. This primary meristem, it further differentiates. The tissue or organ of a plant. It further differentiates it, this primary meristem. For example, protoderm. Procambium, etc. These are the primary meristems. Okay, which originate from promeristem, and promeristem is group of limited number of initials or limited number of cells which has power of division, which differentiates this embryo which differentiates in embryo and forms this embryo. It has a mass of cells known as primary meristem. This primary meristem further differentiates into different tissues or organs of a plant. We will take example protoderm and procanthum. Now secondary meristem. See, this secondary meristem has no origin. No origin. This secondary meristem has no origin. And it arises as per need, whatever and whenever. Whatever and wherever, okay? Whatever and wherever, if there is need, this secondary meristem arises from permanent tissue. It arises from permanent tissue. It arises from permanent tissue, but under some conditions, whenever and wherever it is needed. For example, I will give you an example about it. About secondary meristem. For example, when secondary growth occurs, it gives rise to vascular cambium. This secondary meristem gives rise to vascular cambium, but this vascular cambium arises from intravascular cambium. Intravascular cambium when there is need of formation of secondary growth. When there is need of formation, because vascular cambium helps us in secondary growth. It helps in formation of cambial ringus, which is the characteristic feature of secondary growth. So this secondary meristem, it has no origin. It occurs wherever and whenever it is needed. For example, vascular cambium originates from intravascular cambium and it gives rise to secondary growth. Or cork cambium. Cork cambium is also secondary meristem. This cork cambium arises when there is need of healing. Healing of wound or formation of protoderm. Okay? So this was secondary meristem. This was meristematic tissue based on origin and development of plant. Okay? It has three types: promeristem, primeristem, second. I have explained all that. Now we will go to see structure and origin and structure of this meristematic tissue. Origin, structure and development. Structure and development of meristematic tissue. See, different theories have been put forward to find structure or origin, structure or development of meristematic tissue. Various theories, but among them few theories are acceptable. Among them few theories are acceptable, like histological theory, given by Hammerstein, 1870. What histological theory says, if we are talking of apical meristem, if we take shoot apical meristem, it says this whole structure, it has three parts. We are talking of shoot apical meristem, histological theory of shoot apical meristem. Shoot apical meristem. It had three parts. What are these? Dermatogen, peribellum, and pleroma. These are different proteins which Hammerstein explains this histological theory. Dermatogen, Cerebellum and pallidum. This dermatogen gives rise to epidermis, and cerebellum gives rise to middle layers. It is upper layer, its middle layer, around cortex and endodermis. And this pallidum gives rise to pith and vascular canyon. This was saying of Hannestein in histogen theory of origin, structure and development of meristematic tissue, while Hannestein says this whole undifferentiated tissue has three parts: dermatogen, cerebellum and pallidum, in which dermatogen differentiates into epidermis, cerebellum into middle layer like cortex and endodermis, and pallidum into pith and candium, vascular candium. Second theory was second acceptable theory. This was first acceptable theory. This was the first theory, and the second, which is most acceptable and reliable theory, that is tunica carpus theory. Tunica carpus theory. Tunica carpus theory of shoot apical meristem. It was given by Sichmir. 1924. What Sichmir said? It says this whole tissue, meristematic tissue, like this, it has two parts. This whole tissue is differentiated into two parts. One is tunica, as the name indicates, and another is carpus. Tunica is one or two layer cells. Which forms epidermis. Which forms epidermis. And corpus, as further, suppose one or two, these are the tunica cells. These are tunica cells. It grows here, it goes continue here. I am just saying you, it goes continue here. And rest of the cells, which I am just going to show you. This is tunica. These are corpus. Cells. Okay, and corpus gives rise to central tissue, which includes candium, primary xylem, primary phloem, cortex, pith. These all it shows by corpus. This was tunica carpus theory of shoot apical meristem given by Sichmir in 1924. In short, this is in short what Sichmir says about tunica carpus theory. Now, as far as root apical meristem is concerned, origin, structure and development of root apical meristem. Okay. Again, histogen theory given by Hannestein. in 1870. He again says this root has pallidum, cerebellum, and dermatocalprogeny. This comment, his root epidermal system. If we talk of dicot root, Henstein says, it says this pallidum and cerebellum, dermatocalprogeny. These are the three parts of this root epidermal system of dicot roots, in which pallidum gives rise to central portion, central tissues. Cerebellum gives rise to middle layer tissues, like cortex and endodermis, pith and vascular tissue. And this dermatocalprogeny gives rise to root cap and protoderm. Root cap and protoderm. But in case of dicot roots, this dermatocalprogeny. When we talk of monocot root, if it is monocot root, then only if it is monocot root, suppose we say this is monocot root. Again, histogen theory in monocot root, this calprogeny gives rise to this calprogeny and dermatogeny. Dermatogeny gives rise to root cap and calprogeny gives rise to dermatogeny gives rise to root protoderm and calprogeny gives rise to root cap. This is the difference between monocot and dicot root as per histogen theory, which explains root epidermal system of dicot root as well as monocot. In dicot root, dermatocalprogeny tissue is there. In monocot root, this calprogeny gives root cap and dermatogeny gives protoderm. This was about development of monocot root. And a special point I am going to say here, which is called a quiescent center. This quiescent center, it's a hemispherical or cap-like portion present between root cap and root apical meristem. Hemispherical cap-like portion present between root cap and root apical meristem. For example, suppose this is root cap. Here is a centrally located portion. This is root apical meristem, but this is quiescent center. And the characteristic feature of this quiescent center, hollow portion. This hollow portion is quiescent center, and the characteristic feature of this quiescent center is it is inactive cells. They are not in active state. They are inactive cells and become active on the basis of emergency, due to emergency. Become active only in particular condition. Normally these remain inactive, and it's also called a reservoir of cells present in between root cap and root apical meristem, which are inactive cells become active only in particular conditions. And this was all about plant tissue, different plant tissues, and among different plant tissues I explained meristematic tissue. In meristematic tissue I give detailed explanation of this meristematic tissue. Hope you have understood it. This was all about today. Thanks for watching me.